Alrighty, so welcome to the next class. Today's topic is electronic configuration and continuation of the structure of atoms. We will be studying about electronic configuration, arrangement of electrons in shells and orbits, and then from continuing from what you have learned in O levels, and we will be building on some new concepts which are to be a part of your A levels course. So. Uh, to start with, you know that electronic configuration is the arrangement of electrons in shells or orbits. And the rule for filling the electrons, if you remember, is 2n square. The rule for filling electrons is 2n square. 2n square, where n is, what is n? N is equal to shell number. So shell number, it means that in the first shell, if we put 1 in place of n, you will have 2 into 1 square is just 2. That's why in the first shell, which is closest to the nucleus, and it holds a maximum of 2 electrons. It cannot hold more than 2 according to the rules of filling shells, which is 2n square. So this shell is the smallest shell. It is closest to the nucleus and it can hold no more than 2 electrons. So first this shell is filled. Okay, so the second shell can hold up to 8 electrons because if you place value of n to be 2, so 2 square is 4 and 4 to the 8. So second shell, which is outer to the first shell, next to the first shell, which is also called L shell, it can hold maximum of 8 electrons. You know that from O levels. Then the third shell should have 18 electrons. Third shell has a capacity of filling 18 electrons. 18 electrons can be filled in the third shell. But if it is filled with 8 electrons, even then it is behaving as a filled shell, although it is not filled to its capacity. But having 8 electrons in a shell, uh, except first shell, will make it a full shell. It will make it a stable orbit or make it a stable shell. It is in line with the noble gas electronic configuration because they all have 8 electrons in their outermost shell. So it means that if a shell has 8 electrons, it will behave as a full shell. But this does not apply to the first shell because it cannot hold more than 2 electrons. But the remaining shells, second, third, fourth, fifth shell, they can be filled with the formula of 2n square. That is the maximum capacity. For example, for the fourth shell, if you place it 4, 4 to the 4 square is 16 and 16 to the 32. So in fourth shell, the maximum capacity is, the fourth shell, the maximum capacity is 32. Fourth shell can have 32 electrons. But even then, if it has 8 electrons, it will behave as a full shell. So any shell except first shell can have 8 electrons to behave as a full shell. So this applies to fourth shell, fifth shell, or third shell, as well as second shell. If there are 8 electrons, it will behave as a full shell. But the maximum capacity is different from the eighth shell. Third shell can hold up to 18 electrons. Fourth shell can hold up to 32 electrons because the formula for filling the shells is 2n square and n is the number of shell. 1 square is 2, 2 square is 4, 4 to the 8, 3 square is 3 square is 9, 9 to the 18, and then so on. So this is how this is a rule of filling the maximum electrons, but from your O levels concept, and it is applied to always in chemistry, that if a shell is filled with 8 electrons, it will behave as a full shell. as a stable electronic configuration, because noble gases have 8 electrons in their outermost shell, except helium, which has 2 electrons because it does not have a second, third shell. So remaining noble gases have 8 electrons in the valence shell, and they behave as a full shell. So the writing 8 electrons doesn't mean that it has only 8 electrons. It can have more than 8 electrons. Second shell can have 8 maximum. Yes, it's done. But in third, 18 is maximum. But if it has 8 electrons, it will be filled with a stable configuration like noble gas. And fourth will also be filled with 8 electrons, and it will behave as a stable configuration. But in A levels, you will study when you will study the electronic configuration up to the 36th element. So you will see that the third shell will have more than 8 electrons, and it will go up to 18, and you will yourself do it while doing the electronic configurations. So this is how the electrons are filled. The shells are arranged in increasing order of their energy. The first shell has the lowest energy, and as you go away from the nucleus, as you go away from the nucleus, as you go away from the nucleus, the energy of the shells increases, and energy of the shells increases. So as you go away from the nucleus, the energy of the shell increases. So the lowest energy shell is first shell. Then higher is second shell, and further higher is third, and you go away from the nucleus, the energy of the shells increases. So you know that the rule of filling the shells is that electrons enter into the lowest energy shell first, and then progressively fills up the higher energy shells. This is what you have learned in O level. This is nothing new. But then we will build on the new concepts based on the revising this concepts of your O levels. So magnesium atom, its proton number is 12, so it has 12 electrons. So the electronic configuration will be, the first shell will have 2 electrons, it is filled. Then second shell is filled with 8 electrons, it is also completely filled and becomes stable. But then you still have 2 electrons, so the 2 electrons will go into the third shell, and that's why the electronic configuration is 282. So you can write it like 282. So this is how you write it, and then you have drawn it in the form of shells. So what is the valence shell? You know from your O-level concepts that valence shell is the outermost shell of an atom, or that's outermost shell is called valence shell. So in magnesium, the valence shell has 2 electrons. Valence shell is the outermost shell which is furthest away from the nucleus, and it is the outermost. You remember that shells or orbits are imaginary paths. If electron is there, this path exists. If the electron is not there, this path does not exist. So it means that when the third shell has 2 electrons, and there is no electron in the fourth shell, so there is no existence of the fourth or fifth shell. These shells only exist when electrons are present in that area around the atom, around the nucleus. So these are just lines that we have drawn for our imagination. Actually, these lines are not drawn in space. We just draw it for our own visual understanding. So if electron is there, then the shell will exist. If the electron is not there, the shell will not exist. So magnesium has only 3 shells, no fourth, fifth, sixth, fifth shell. It has only 3 shells. And third shell is the outermost shell. And the electrons present in those shells, the outermost shell, are called valence electrons, and that makes the valency of the atoms as well. So the valency of magnesium has 2 electrons in the outermost shell. So outer electronic structure draw करना हो तो that will make us a simpler diagram. You can be asked to draw only the diagram to show only the valence electrons and not the electronic structure. The previous diagram that we have done, we have seen, is a complete electronic structure. You have shown all the electrons in an atom. But if you are asked to draw only the valence electrons, then you don't need to draw the inner shell, just you need to draw the nucleus. And even in the nucleus, you can just write the symbol. For example, 12 neutrons and 11 protons, so it's sodium, you can just write Na and Na, and then you draw a shell, which is outermost shell, and then you add one electron in sodium, because the sodium has electronic configuration of 281, so it has one electron in the outermost shell. And you don't need to draw the inner shells, first shell and the second shell, you just need to draw the third shell, which is the outermost shell, and it shows that it has a valency of one electron in the outermost shell. uh, the valency or the electronic configuration is very important. We have studied in the previous class of atomic structure that the proton number is an identity of an element and it cannot be changed. It can never be changed. If the proton number changes, the element will be different from the previous one. Every element has a distinct number of protons in its nucleus. And you know that when an atom is electrically neutral, it means that the number of electrons are equal to the number of protons. And so, according to the proton number, when you have an electronic configuration, then there will be some valence electrons. And the chemical properties of an element depends on the number of valence electrons, or you can say valency. The valency is basically responsible for the chemical behavior, because when you will see, you have studied in O levels that when a bond is made, electrons are lost or gained in the valence shell, or they are shared in the valence shell. Inner shells do not involved in any kind of chemistry unless you break an atom and you cause some nuclear fission or something else. But it is not chemistry. It's like nuclear physics. So you are not breaking atoms into its pieces. When you are reacting an atom with another atom, the electrons that involved in a reaction are in the valence shell. Only valency electrons do react. So if you want to react sodium with any other element, the electron in the outermost shell, that is one electron, the outermost shell electron will be lost to form an ionic bond. And the same case with potassium, it loses one electron and it also forms plus one charged ion just like sodium. And they both have same chemical behavior. And that's why in periodic table, you will see that they are placed in the same group. So elements in the same groups are vertical columns, top to bottom. So sodium and potassium are in the same group number one. Why they are in the same group? Because they have same chemical properties. And why they have same chemical properties? Because they have same a number of valency electrons, same kind of electronic configuration, and they have one electron in their outermost shell, which makes their electronic structure quite similar. So if you see in periodic table, there are rows and there are columns. The rows are called periods, and periods you extend from left to right. And when you move across a period, there is no similarity in any chemical property, because you are moving from you're moving from one element to the other, and the electronic structure and valence electron number also changes. So if you see hydrogen, it's one, then helium is 2, lithium has 3, and its electronic configuration is 2 1. Beryllium is 2 2, then boron is 2 3, and so on. So as you move across the periodic table in the periods, the number of protons increases, and so does their electronic configuration changes. And elements across periods are never the same. They are different, properties change quite distinctly. One more thing from this diagram that you can see is that if you move from top to bottom in any group, you can see group number 8, which is now called group 18, or you can see group number 1. You will see that as the number of shells are increasing, the size of the atom is also increasing. Lithium in group 1 is the smallest, then sodium is bigger because it has 3 shells. Then potassium is even bigger because it has 4 shells. So as you move down the group, the atomic radius increases because more shells are added, and the distance from the nucleus and the valence shell all increases. And radius is always from the center to the outermost line outermost subshell. So atomic radius, which is the distance between the center of the nucleus and the valence shell, actually it's an average distance because I've told you that shells are not circular; they are elliptical. So we need to take different measurements from different places from the center of the nucleus to the valence shell, and then we have to take their average. So, but even then, the simple diagram of the periodic table is showing that when you move from top to bottom in a group, the atomic radii increases. But if you move from left to right in any period, you can see period number 2 or 3, from lithium to neon or from sodium to argon, you will see that the size of the atoms shrinks. Size of the atoms shrinks. It becomes smaller. The reason is that the shells are not increasing. You see, in any period number 2, all elements have 2 shells. In period number 3, all elements have 3 shells. But you see the number of protons and electrons are increasing. For example, in third period, sodium has 11 protons, magnesium has 12, aluminum has 13, silicon has 14, and argon R2 has 18. So the number of protons are increasing, the number of electrons are also increasing in the valence shell, and that's why the attraction between the nucleus, the protons, and the electrons in the outermost shell is increasing. Shells is not increasing, so protons attract the electrons out of the outermost shell and pulls them closer to the nucleus and makes the size of the atom smaller. So when you move from left to right, atomic radii shrinks. But when you move from top to bottom, the atomic radii expands, increases in size because of the addition of a new shell. And the distance from the nucleus and the valence shell increases down the group. But from left to right, as there is no difference in the shell number, but the number of protons and electrons are increasing, therefore attraction is increasing, and that's why the atomic radius is decreasing. There is one more factor you haven't studied that in O levels. I'm introducing it to you right now. It's something new maybe for you. That is called shielding effect. Shielding effect. I hope you know about the word shield. So shielding effect. So what is shielding effect? So it is the reduction in attraction caused by the inner shell electrons. So it is the reduction in attraction. You can say that between nucleus and nucleus and valence electrons caused by the inner shell electrons. So you see that when you go down the group, the shielding effect also increases. For lithium, it has only one shell in between the nucleus and the outermost shell. But for sodium, it has two shells, first shell and the second shell. In potassium, it has three shells. And greater the shielding effect, lesser the attractions. So you see, it is a reduction in attraction. So greater the number of inner shell electrons, so greater is the reduction in attraction. And when the reduction in attraction occurs, the size of the atom increases. So down the group, or shell number increases, shielding effect increases, and the attraction becomes lesser, and that's why the size of the atom increases. But when you are moving from left to right in the period number 3, if you see, all elements have two shells as a shielding effect, and the distance is that's why decreasing, because shielding effect is same, number of shell is same, but the number of proton and electron is increasing, and the attraction is increasing. From in the nucleus the protons are increasing, and then the outermost shell electrons are increasing, so the attraction becomes stronger. And that's why nucleus pulls the electrons of the outermost shell closer to the nucleus, and that's why the size shrinks. So this shielding effect is a new concept. इसकी definition अभी आपको मैंने लिख के दी है ये. It is the reduction in interaction between the nucleus and valence electrons caused by the inner shell electrons. So greater the number of electrons in the inner shells, greater the number of inner shells, greater the shielding effect, and greater the shielding effect, lesser the attraction, and lesser the attraction, larger the radius. ये concept जो है ये आप जो है, this is a new one, and you have studied the variation in atomic radii down the group and across the period. So we know that periods and groups, we have studied that elements have same number of electrons in a group, so that's why their chemical properties are same. So now we are moving on towards the formation of ions. You have studied about that in your O levels as well. Formation of ions. So ions are charged particles, and we know that atoms are electrically neutral because they have equal number of proton and electron. But when an atom either gains or loses electron, it becomes an ion. So an ion has either more electrons than protons, that is called efficiency of electrons, or they have lesser number of electrons than protons, so you can say that they have a deficiency of electrons than protons. So whenever an ion is formed, it is due to the loss or gain of electrons. If there is no loss or gain of electron, ion is not formed. As in covalent bonding, no ion is formed. So ion has a different number of protons and electrons. Positively charged ion carries a positive charge, and there is a negative charged ion as well. Positively charged ions are called cations, and metals forms cations. Metals forms cations. So metals forms cations. They lose electrons in their outermost shell, and you know that sodium forms a sodium ion which has +1 charge, 1 plus charge, and magnesium ion will form 2 plus charge. Aluminum will form 3 plus charge because they have 1 electron, 2 electron, and 3 electron respectively in their atoms, so they can lose 1, 2, or 3 electrons. Non-metals usually form anions. They gain electrons, and they gain electrons to become stable. Remember, whenever an atom loses or gains electron, the basic concept behind that is to become stable, to have a stable arrangement of electrons like noble gases. So when metals lose, they go towards the inner shell. They lose their outermost shell. But in non-metals, their outermost shell remains intact, and more electrons are added into it, and the electrons are added until they have 8 electrons. Just like chlorine atom has 7 electrons, and it can gain only 1 electron to form Cl minus 1 ion. Oxygen has 6 electrons, so it can gain 2 electrons to form 2 minus ions. Sulfur also forms S2 minus. Nitrogen or phosphorus can gain 3 electrons because they have 5 electrons in the outermost shell to become like stable. So we also already have studied that in O levels. So metal atoms lose valence electrons to form positive ion. We see sodium atoms, it has 281 configuration. It loses 1 electron, and outermost and it has 10 electrons. So more protons, 11 protons plus 11, 10 electrons minus 10 plus 11 minus 10 give you an answer of +1. So you see this electron is lost, and you will have a sodium positive ion. And you know, if you remember in O levels, that how to write an ion. So you use a bar bracket to put the ion in the bar bracket, and you put the charge outside the bar bracket as the power of the bar bracket. And you see you have now only 2 shells in sodium ion rather than 3 shells in sodium atom. So its electrons is lost. For calcium, you see it has 2 electrons in the outermost shell, and it will lose 2 electrons. Again, the outermost shell is lost, and it will have 3 shells now, and the electronic configuration will be 2882 से change हो जाएगी to 288, sorry, and its outermost shell is completely filled now. and it has a stable arrangement of electron by losing two electrons. So you see ions are always placed in bar bracket. You will never see any overlapping in the ions. Ions are single entities. They can remain as such. Okay, so that's why you do not need to show any overlapping or any crossing over of the valence shell. An ion is a single particle which can exist in molten or aqueous solutions. So anion, how an ion is formed, you see chlorine atom has gained one more electron to become stable and have 8 electrons in the outermost shell. But in doing so, it has a charge of -1 because one electron is gained. Non-metals, when they form negative ion, their name also change. So their names ends with ides. Metals name do not change. Sodium remains sodium ion, magnesium remains magnesium ion, and same thing with any positive ion. Aluminum remains aluminum ion, zinc remains zinc ion. But non-metals, when they form negative ion, their name changes from chlorine to chloride, oxygen to oxide, phosphorus to phosphide, and so on. So you see, oxygen is now called oxide. It has gained 2 electrons and it has a charge of 2 minus. Octet is complete. So these are some common ions. ये आपने O level में formulas भी याद किए हुए. You need to learn these formulas to write your equations, to write the formulas correctly. So आपके पास O level में जो valence chart है, valency chart, उसमें symbol, उसका charge, you must need to learn that. And there are some radicals as well. You need to learn those radicals as well. Just like ammonium ion. Ammonium ion is a molecular ion. What is a molecular ion? It's a molecule which has two or more atoms, but still it has a charge. Ammonium ion is the only positively charged ion. The rest of the molecular ions or radicals are negatively charged, like sulfate, phosphate, nitrate, chromate, carbonate, dichromate, manganate, etc. So these are the charges on various elements. Plus ones, hydrogen plus one, potassium, silver, sodium. Group 2 elements have plus 2 charge, and some of the transition elements such as copper and zinc and iron 2. For variable valencies, you write the number as a Roman number, iron 2 and iron 3. It means that iron 2 has a charge of plus 2 and iron 3 has a valency of plus 3. Aluminum is plus 3. So you need to rote learn that. You must have to remember that. So in negative ions, bromide, chloride, these are group 17, group 7 elements. So they have a -1 charge. Hydroxide and nitrate, they are radicals, and they need to learn that. OH -1, NO3 -1. Carbonate, CO3 2 minus, oxide 2 minus, sulfate 2 minus, and that's about their valency.